If you've been coding in any language before, chances are you've worked with dynamic arrays, lists that grow or shrink in size. In Rust, we use vectors for that. They're powerful, type-safe, and come with a ton of methods that make working with collections really smooth and safe. Let's get into the code. All right, so first, let's create a new vector. You can define an empty vector like this. Okay, let's walk through this. We're declaring a vector of type i32, which means a vector of 32-bit integers. And notice that it's mutable. That's important because if you want to add or remove elements from a vector, it has to be mutable. We use push to add elements to it, just like pushing items into a box. And when we print it, it shows 10, 20, 30. Perfect. Now let's say you already know the elements up front. Instead of using vector, new, and pushing, you can initialize it like this. That's using the vec macro, which is a convenient way to create a vector with initial values. This is super handy for static data or test examples. Let's talk about accessing elements. Here's a simple example. We are accessing the element at index 1 of the nums vector, which is the second element, 100, and assigning it to a new variable named first. So far, so good. But here's something important. Accessing out-of-bound indexes in Rust will panic at runtime if you're using square brackets. For example, instead, use get to safely access values. It returns an option. This is one of Rust's awesome safety features. We're forced to handle the possibility that an index might not exist. That's how Rust avoids so many bugs we see in other languages. Okay, now let's talk about iteration. Here's how to loop over a vector. We use &colors to borrow the vector. We don't want to move ownership. This is crucial when you still need to use the vector after the loop. Let's try a mutable iteration. Let's say we want to double each number in a vector. Notice the asterisk number. Since we're getting a mutable reference, we have to dereference it using the asterisk. Now what if you want to remove elements? Let's see pop and remove in action. So, pop removes the last element and returns an option, and remove, index, removes the element at a given position. Let's test what happens with pop when the vector is empty. See how that works with safety in mind? That's Rust for you. Now here's a fun one, vector of tuples. Here we are initializing a vector named students. This vector holds tuples, with each tuple containing a student's name, a string slice, and their score and integer. Then we iterate through each tuple in the student's vector using a for loop. In each iteration, it destructures the tuple into two variables, name and score, and then prints a formatted string to the console indicating the student's name and their corresponding score. Tuples inside vectors work great when you want to keep related pieces of data together. What if you want a vector of vectors? Let's do a matrix-style example. Here the vector holds vectors of integers. We iterate through each vector. That prints a nice 3x3 grid, just like you'd expect in any 2D array. Let's wrap this up with an important tip. Vectors are stored on the heap, not on the stack. That means they can grow in size dynamically. Arrays, as we discussed earlier, have fixed size and are usually stack allocated. This makes vectors your go-to for collections that need flexibility. Here is a quick challenge for you. Write a program that finds the maximum number in a vector of integers. Drop your code in the comments. I'll be reading them. Vectors are essential. You'll use them all the time, in game loops, data processing, handling API responses, you name it. Mastering them early will pay off big time as your Rust journey continues.